Hello friends, the topic for today is evolution of electronics. In this 21st century, every day we are dealing with electronic circuits and devices in some form or the other. For example, electronic gadgets, home appliances, computers, transport system, cell phones, cameras, TV, etc. Now, to learn electronics, it is necessary to know about the brief history of electronics. You will be inspired by the scientists who have discovered and invented different electronic devices. In today's video, I will discuss evolution of electronics from vacuum tubes to very large scale integrated circuits, that is VLSI. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you will get notifications for our future videos. The topic for today is evolution of electronics. Let us start with introduction. Now, the word electronics, actually this originated from the word electron. Electronics is a branch of science dealing with theory and use of devices in which electron travel through vacuum, gas or a semiconductor medium. So these are the different mediums in which the electrons travel, and the electronics is the field of science which deals with the motion of electrons under the influence of applied electric or magnetic field. So electronics has evolved around three components, basically: vacuum tubes, transistor and integrated. Let us see the first era of vacuum tubes. So here first we'll take the diodes. So Thomas Alva Edison discovered the electronics will flow from one metal conductor to another through vacuum. So this is known as the Edison effect. And in 1897, John Fleming, he applied this Edison effect in inventing a two-element electron tube called the diode. So this tube, it is the vacuum tube diode. Here you can see this is the early vacuum tube, or they are also called as the valves. It's a glass, made of glass, and inside there is a vacuum, and then that will be used for there are two electrodes in case of diode. Here you can see the circuit. So this is the vacuum tube, and there will be flow. Here this is the battery, and there will be flow of electrons in this case in the valve. Then in 1906, Lee D. Forest, he utilized the Edison effect to invent another element, that is the triode. It is a three electrode device. So here you can see there is an anode, there is a cathode, and there is one more element that is called as the grid. So the grid will control the flow of electrons. That's why it is called as the control grid. You can see here this is the control grid, this is the cathode, and this is the anode. and this is the glass tube, and these are the connector. So this is the picture of D.D. Forrest. He invented this triode in 1906. So this was the this triode was instrumental in amplification and transmission of electrical energy. So here amplification means it is multiplying the energy in one form, and then the energy is transmitted. But these vacuum tubes, they were large in size, bulky, and because of the glass they were fragile. So and they consume high power. Then came the transistor era. In 1948, three scientists, John Bardeen, Walter Bretton, and William Shockley, they developed transistor at the Bell Laboratory, and then they were given Nobel Prize for their creation in 1956. So these are the three scientists, and this is the transistor which they have developed. You can see it here. Now transistor, again, it is a three terminal device: base, emitter, and collector. These are the three terminals of the transistor, and this is just a crude model they had developed. And then actually the modern transistor is a junction transistor, and was developed in a same semiconductor piece. So the P, suppose you take, there are two types of transistors, PNP and NPN. So NPN, so the P is sandwiched between two N. So if it is done in a same semiconductor piece, it is called as the monolithic. So the junction transistor were developed, and the two semiconductor materials, that is germanium and silicon, they were used to make the transistor, and it was very popular, and it was used in different electronic circuits. So the diode and transistors, now they were made from the semiconductor devices, and this transistor, it became very popular, and it changed the whole electronics industry. So this metal transistor replaced the vacuum tubes as a semiconductor device. Yes, they are compact compared to the vacuum tubes, and they are light in weight, low cost, and the power consumption is also very less, and they have longer life if operated in the say same operating condition. That's why they became very popular, and that was a revolutionary change in the electronics. You might be knowing that the radio, they were called as transistor at that time, because all the radio receivers, they had few transistors that would receive the radio. So earlier we had the AM radio, and then now we are having the FM radio. Then after this transistor was invented, then in 1958, Jack Kilby is the person, Jack Kilby. So in 1958, he came out with an idea of making the IC, so integrated circuit. So here he tried to put several components on a single chip. So that was, he was the first who proposed this. But then ICs, now they are capable of say several thousand components on a single chip. So accordingly, they are classified as small scale integration, medium scale integration, and large scale integration ICs. And here in the figure, this is the actual circuit which was developed by CLB, the first integrated circuit. And here you see the silicon wafers, which contains number of integrated circuits or chips on a single wafer. So there are millions of chips on this wafer. So let us come to the summary of history of electronics. So it was 1890 Hertz performed experiment on generation of electromagnetic wave. So then J.C. Bose discovered the propagation of radio wave. The electromagnetic waves, they are the waves which are radiated through the space. Then in 1895, Lorentz postulated the existence of electrons. And then in 1897, J.J. Thomson verified the existence of electrons. And then 1897, Braun invented the first electron tube, and then came the Fleming's diode, that is vacuum tube. Then 1906, T. Forrest invented the triode, again a vacuum tube. But since the vacuum tube were bulky, they were replaced by the transistor. Then in 1930, we came up with the monochrome television, and in 1950, the color television was invented. And in 1963, the Institute of Electrical and Electronics Engineers, that was formed, and this is the institute which is responsible for different standards. Nowadays we have the different standards for networking, even the Wi-Fi connection, 4G, 5G, all these standards, protocols, they are defined by the Institute of Electrical and Electronic Engineers, IEEE. That's why they are called as the IEEE standards. So this is just the summary of history of electronics. Then let us see the evolution of transistors. How transistors they were how evolved. So first, the three scientists, out of them, two of them invented the point contact transistor, and then Shockley, he came up with the junction transistor. And then the commercial production of transistor that started in 1950. So you can see here I have shown some of the transistors. So this is a power transistor 2N3055. That is the number of the transistor. And these are the other transistors which are three terminal devices. These are the three terminals of the transistor. Generally the base will be the middle, and emitter, collector, those terminology that will depending on the package. The three terminals be defined for the depending on the package. So this was the junction transistor, and then the junction trend, it was carried out with the JFETs, junction field effect transistor, and metal oxide semiconductor field effect transistor, MOSFET. So that was developed during 51 to 58. So that has, so MOSFETs, they are more, can make them density can be increased. So they are useful for the particularly the processors, ICs. Then in 1958, Kilby gave an idea of monolithic circuit, that what we have discussed. Concept of integrating device and circuit elements onto a single silicon chip. Okay, apart from the transistor, other circuit elements like capacitor, resistors, they were integrated on a single silicon chip. So that we call it as the monolithic circuit. Then in 61, Fairchild and Texas Instruments, these are the two companies which came out with the commercially integrated circuits, ICs. ICs that will be coming with the, say, 14 pin, 28 pin, 40 pin. So that is the packaging, dual inline packaging for the IC. Then let us see the evolution of integrated circuits or ICs. So in 1950, a single transistor was incorporated in a single chip. Then in 1960s, small scale integration, so less than 100 components per chip, that was possible. You can see here the 16 transistors were put on a single chip in the form of this quad gate, that is the transistor logic gates. So AND gate, NAND gate, so all these ICs, they are the TTL ICs, and they are having around 16 transistors in single chip. Then in 1966, they came with the medium scale integration. So the components per chip, that is increased from 100 to 1000. And then in 69, they came up with the large scale integration. So the count increased up to 10,000 components per chip. So you can see here in 1970s, they came up with the 8-bit microprocessor chip. So they were having around 4500 transistor. Then later on in 70s, they came with more transistors. Say for example 8085, it has 6200 transistors. Then in 1975, they came up with the very large scale integration, VLSI, that is greater than 10,000 components per chip. So you can see in the 80s, they came up with 275,000 transistors on a single chip. So it was a 32-bit microprocessor, 80386. Then in 90s, they came up with 3100,000 transistors. So the number of transistors again increased. Particularly the Pentium chips, they were made with so many transistors. And then in 2000, they came up with 592000000. So the number of transistors or the density, say, on the integrated circuit doubles every 2 years. So that is called as the Moore's law. So every year the density of integrated circuits, or in this case the transistor density, it is getting doubled. So if you consider from 1960 2000, 40 years, so every 2 years it is getting doubled. That's why you get a very large number of transistors now. It's possible. So now they have gone beyond the VLSI. We call it as the ULSI, ultra large scale integration. So this is still going on, and the evaluation of this will further continue and will be getting. That's why we are nowadays we are able to get. So we'll have to thank the VLSI technology, because of which we are able to get so many functionalities on our mobile phones, because they are using the VLSI chips, and the functionalities they are integrated on that chip. And it is very now the new chips are manufactured, and we are getting the new mobiles every 2 months. So with this we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail, or Instagram. Then if you like the video, press the like button, share with your friends using this icon on the YouTube, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon, because if you press the bell icon, if you subscribe and press the bell icon, then you will get notifications for our future videos on this subject. Then thanks for watching. Have a nice day.